I'm not sure how I'm going to follow that talk because people are doing things to actually improve the language, and I'm just going to complain. So my talk is called, if we could get the slides, Simplicity in Go. It's a topic that doesn't get much attention in Go, right? But I hope that I'm going to provide a different take on this today. There we go. All right, so when I was in college, I took a sociology class, and my professor gave me an assignment. And he gave me 3 constraints. The first one was that you're a parent in a fictional 5-person family. The second was you and your spouse may only make minimum wage. And the third are that your children are too young for school. The assignment was to create a weekly plan for my family. So this is like the wrong thing to ask an engineer, right? Because it's a problem, it's like, oh, I can solve this, it's no problem. You got your food, your job, your childcare, family plan, right? So I went out and I scouted a lower income area. I found an apartment, I found a restaurant that one of the parents could work in. The other parent would stay home and take care of the kids. And I thought I had this solved. For food, they had hot dogs. Because why wouldn't you want to eat hot dogs? The apartment was probably too small for a 5-person family, and the restaurant didn't really exist. And the other problem was that they ate hot dogs for breakfast, lunch, dinner, every day, all day hot dogs. So this is the plane flying over my head. And for those of you not familiar with that phrase, it just means I didn't get what my teacher was wanting. I got a poor grade on that paper, and it made me start thinking, what was my professor really trying to, impart to me? And of course, what he was trying to teach me was that in the United States, it's impossible to subsist on a minimum wage income and be considered above the poverty line. So what was I doing? I knew the problem. I thought I knew the problem. I knew the outcome. And I just kind of did whatever I needed to solve what I thought the problem was. So this reminded me of a chapter in a book that I really like called The Pragmatic Programmer. It's a pretty good book on just kind of the fundamentals of software engineering. And there's a section there called Programming by Coincidence. And programming by coincidence is essentially when you just mash keys until it works. Like, you have a problem, you don't really understand what the root cause is, so you just keep trying things until it works. And maybe in the future, it breaks again, and you still have no idea why it was broken. So the takeaway from this chapter is don't program by coincidence. Don't do that. This is what I was doing to solve my assignment. I solved it, but I really didn't understand what the teacher was trying to impart. So what does this have to do with Go and simplicity? We see the end result, which is simplicity, right? It's why most of us have gravitated towards the language. But do we really understand why Go is simple? What the motivations are? Without knowing the why, I've witnessed that we begin to justify some pretty strange things in the community. And these are some examples. So problem 1, I've got a large team. There are build or test activities the team needs to do consistently. And you can't do these activities through the Go tool. So let's say you're trying to standardize on a flag that you're passing to the Go tool. Can we use a build system? Right? That's what build systems do. They standardize the build process. This guy says no. Problem number 2. I have a job to do. My boss has asked me to write a web service of some kind. And I don't want to worry about the common idiosyncrasies of doing web development or whatever my boss has asked me to do. Can we use a framework? I guess not. So let's look at another situation in which we might encounter. Problem 3. I have a large code base, kind of a trend here. I need to solve common problems and socialize the solutions. Can we use design patterns? And I was really happy that Peter went before me because he kind of broke the ice with design patterns. And I want to pause here because I know this is kind of a hot button topic in the Go community. And when I say design pattern, I don't necessarily mean the Gang of Four design patterns, singleton, that kind of thing. You know, think maybe GopherCon 2014, there was a compendium on compendium on channels, I think it was called, on how to use channels. That's a design pattern, right? It's a common way to do things. Gosh, really? So problem number 4, I have a large code base, and I want composable, testable, simple code. Can we use dependency injection? That's kind of harsh. Problem number 5, I need repeatable builds. I need isolation from changes to libraries. Can we use vendoring? Now, I think it's interesting because vendoring in some circles was considered taboo before the Go developers said this was okay to do. Okay, so who is this person? Because they're kind of annoying. So this is a hipster programmer. Their mantra is Go is simple, right? They're resting on this idea of simplicity, but they're not really thinking things through. And the previous slides, you know, it's okay to disagree. It's okay to have an opinion. That means you're engaged. You're thinking about things. That's not the point, whether those things are right or wrong. Just have a reason for what you're doing. Don't just rest on Go as a reason, because it turns out the reason Go is simple is multifaceted. So then what's really going on? Where's the miscommunication coming in? Let's work backwards. We'll start with our premise, which is simplicity. Does anyone know who this is? This is Alan Kay. And a previous talk referenced him, which was also good. So in 2009, he gave a talk called Normal Considered Harmful. And it's a great talk. If you watch it a few times, it'll bend your mind a little bit. You can watch him predict WebAssembly 6 years ago. And the primary reason he gave this talk was he was trying to get universities back into the research space. But there was a point that he made that I thought was really interesting. And that was, he posited the question, is computer science really a field? Because from his perspective, it behaves more like a pop culture. So what he did is he brought up a screen with 9 faces on it, and he asked the class, can you name these people, just like I did? And no one could. I couldn't. I still can't. But this was interesting to him because in a field like physics, you'd be kicked out, right, if you didn't know who Newton was. But we kind of just abide that for some reason. So I think this is the first issue that's kind of clouding this idea of Go and simplicity, this idea of pop culture. Go's still kind of young, and there's a lot of incremental development going on. But I think sometimes it can just cloud this idea of simplicity. So the second thing is because Go is new, it's still kind of possible to know everything about everything, right? It's a small language. Libraries and frameworks are still being developed. We're still kind of in that space where you can know just about everything about Go. So we've got this concept of familiarity or ease. So I was doing some research for this slide about familiarity or ease, and I came across a great kind of conversation between two people. There was this person asking what the best web framework to use in Go was. And here was a response. You don't need framework. But I've made my own package that has what I look for in frameworks without the risk of immature frameworks. So this was kind of strange to me. And by the way, I've modified this quote just enough so you can't Google it and find this person, because it's not my intent to call anyone out here. But I thought this really demonstrated this concept of familiarity or ease. People want to gravitate to what they already know. And I think there's value in things like frameworks. Oh, going backwards. So I think this is the second issue. Third issue, appeal to authority. How many people have heard, if it's good enough for the Go standard library, it's good enough for me? So this is not especially helpful. The Go developers are steering a language. You're probably not steering a language, so don't act like you are. And there's another problem with this, which is the absence of something doesn't necessarily prove anything. So here's Russ Cox, and just as an aside, Russ, it was really hard to find a picture of you. So here we see Russ posted this on Hacker News a few months back. Someone was kind of claiming that the Go developers were not going to implement generics because of political reasons. And Russ says, I'm sorry, but no, generics are a technical issue and not a political one. There are deep technical issues that must be solved to fit the idea of generics into Go in a way that works well with the rest of the system. And we don't have solutions to these. So here we see someone drawing false conclusions based on the absence of information. This is a failed attempt at appeal to authority, if you will. So I think this is kind of a third issue that's clouding the idea of simplicity. So what's this? If you said a mess, I would accept that answer. Believe it or not, behind that yellow mess is a rack of servers. So why do we have methodologies for wiring server rooms? So this doesn't happen, right? Why don't you code in something like Notepad? Because you need something more powerful to do your job. In essence, it's because large and complex things are large and complex. Now, over the past, 30 years, 40 years, we've developed techniques to control that complexity and mitigate it. But a lot of the times, what I see in the Go community is this kind of trend to try and take small examples and use them in large systems. And when I was trying to think of an example for this, the best thing I could think of is inversion of control. So let's say you've got this function here, it processes foo, and it calls a command line to generate some JSON and then parse it and then do something with that parsed structure. What's wrong with this function? Besides the fact that I'm ignoring the error. So here we've got the exec command being called, which is just fine. But what if we wanted that command to time out? Or you wanted standard out and standard error? Or you wanted to set environmental variables before you ran the command? This example might be perfectly fine for small programs or throwaway programs or programs that aren't going to evolve very much. But in large systems, maybe what you want to do is use inversion of control and pass in this concept of run. And you can do it in the function. You can set it as a structure member variable. It doesn't really matter. But I thought this was a great example because I've had this conversation several times with people. In large systems, inversion of control can really help. And I'm moving backwards again. So I think this is kind of the fourth issue, fourth and final. Using small examples and small projects and trying to extrapolate that type of approach into large programs. So we've kind of gone over maybe some anti-patterns. But now let's examine what really is driving Go simplicity. Naturally, we're going to start with Rob Pike. So in 2010, he gave a talk at Princeton called Another Go at Language Design. And he says, Go design aims for being easy to use, which means it must be easy to understand, even if that sometimes contradicts superficial ease of use. Now, that last clause is really important, even if that sometimes contradicts superficial ease of use. This goes back to what we were talking about earlier with ease versus simplicity. Sometimes it's really easy to do something, but maybe it leads to a more complex system. So Rob here is touching on something that someone else gave an entire talk on. Keep hitting the wrong button. This is Rich Hickey. He was also mentioned earlier. And in 2011, he gave a talk called Simple Made Easy. And he addressed this topic directly. It's a great talk. It's really engaging. It's important. I highly recommend watching it, even if you're not interested in Clojure. So the premise was just what Rob said in his talk. This idea that easy does not necessarily always equal simple. And the best quote I could think of to distill down is this. He starts off with saying, the average juggler can do 3 balls. The most amazing juggler can do 12. Compared to the complexity we create, we're all statistically at the same point. So what he's doing here is he's kind of setting the stage, saying that there's no one in this room who's so above and beyond everyone else that they can just handle any amount of complexity. And he goes on and he says, you have to make a decision. How many of those balls do you want to be incidental complexity, and how many do you want to be problem complexity? So here, incidental complexity is complexity forced on you, either by the language, your environment, or a terrible boss. Problem complexity is the thing that you're trying to solve. Go is getting this right. They're removing the incidental complexity so that we can focus on the problem complexity. The ratio of incidental complexity to problem complexity is very small, but you can raise it quite quickly. For example, if you try to extrapolate those small program examples into large systems. So this is Mark Miller. He also works at Google, and he's on the ECMA committee. And I saw this quote just recently, and I had to put it in here because I felt it directly addressed something else that Go is trying to get right. So he says, for a small language, a new feature's general cost and added complexity are also still visible to everyone. Once a language gets beyond a certain complexity, the experience of programming it is more like carving out a subset of features. So this is what Russ was talking about this morning. We don't want this to happen, right? We don't want to go into another Go code base and not be able to do the things we're used to. Or conversely, we don't want them to do things we're unfamiliar with. Rob Pike again. So Rob says consensus drove the design. Nothing went into the language until we all agreed that it was right. Some features didn't get resolved until after a year or more of discussion. So here we see this concept of the Go team really putting thought into what comes into the language and trying to control that scope. They're keeping the language simple to keep that incidental complexity down. And going back to Russ's post on generics, and I think Dave's going to kill me after these slides. He says, to be very clear, we acknowledge this fact. There are definite disadvantages to not having generics. Programming language researchers are sometimes disappointed that Go hasn't picked up more of the recent ideas from literature, but those ideas simply haven't had the time to pass through the filter of practical experience. Again, this concept of trying to get it right the first time. They're being vanguards of the language to make sure that we don't end up with something like C++. Apologies to C++ programmers. They don't want Go to be so large that you have to carve out a subset. So all of this is contributing to Go simplicity. But it's not useful if no one's using the language, right? So there's kind of this keystone to Go, which is, again, Rob saying, programmers are most familiar with procedural languages, particularly from the C family. They need to get programmers productive quickly in new language means that the language cannot be too radical. So this is tying all of that simplicity together by making Go approachable. I mean, again, this morning we saw a new programmer be able to come into Go and be productive in an amazing amount of time. And I think Go's seen pretty good adoption. You guys are proof of that. So we've got all these ideas contributing to simplicity. And these are the things that drive all of the features we know Go is great at. These are the things that Go keeps simple. And they also, most importantly, keep Go fun. So all of this can be boiled down to, I think we're reacting, we're not thinking. I'm concerned that we're using Go's simplicity as a scapegoat to make poor engineering decisions and discard things that are useful to us. The Go developers are thinking really hard about what to leave behind. Are we? Go's still young. The pop culture is still in full swing. But we still hear so often that Go is this very pragmatic language. And while everyone else is debating, we're actually getting work done. I'd like us to continue with that pragmatism. If something's useful to your team, use it, unless you have a good reason not to. Don't rest on this idea of Go simplicity, because you guys familiar with the hill climber problem? Finding the global maximum versus the local maximum? If you're this person, you're fighting your problems here, and you should be fighting them there, in the business domain that you're trying to solve. Don't simplify by coincidence. Thank you.